Okay, so now comes the fun part of IV, which is IV drip rate calculations. So typically, the first thing you need to know is if you take a look at your bags, it says IV administration set. It gives an expiration date, which these are expired. Okay. So we're going to use them for practice, but it's also going to tell you the drip rate factor. Now, you're not going to be able to see the drip rate factor on yours, Raina, because I had to take yours out of a separate bag. But if you would please, where do you find the drip rate factor on this?
Right at the top.
Nope. Look at the very bottom left-hand side. It says 15 drops per what?
Per milliliter.
Per ml.
This is at the top.
So drip rate factors. Drip rate factor is very important in drip rate calculation. Why? Because it's going to be a function mathematically of how fast the drip rate's going to be based upon how much fluid the doctor says the patient needs. So we need to be able to read an IV tubing set. So you need to be able to see where the drip rate is located. For pediatrics, for babies, small children, small surface body mass, we have 60 drops per ml. Normal tubing is anywhere from 10 drops per ml all the way to 15 drops per ml.
For whom, this one? 10 to 15.
So that's the normal IV drip rate. Okay, normal IV drip rate.
So this is pediatrics.
Oh, I'm sorry.
Just a normal.
Okay,
So the top one,
this is for pediatrics. 60 drops per ml is for pediatrics. 10 drops per ml or 15 drops per ml is usually the standard tubing drip rate. Yep. Okay, so these are drip rate calculations. We're going to see how these actually apply in just a short second here. I just need to get a bag. IV bag. Okay. So this is a bag of lactated ringers. Okay? Typically, lactated ringers, depending on what the additives are, can be hypertonic or hypotonic. But you can see it's got a lot of different additives in it. Look at your IV bags. Your IV bags are basically normal saline, aren't they?
Yeah.
What does it say? 0.9 normal saline, right?
yes.
Okay, so what we're going to do first is I'm going to show you how to spike a bag, and I'm going to show you how to spike a bag so you'll never get air bubbles in your tubing. It's very cool. So what I'm going to have you do, did everybody get their little chuck pads? Because we're going to be leaking all over the place here since these are already spiked. So can we, Asia, can you pass out the chuck pads? Okay. So once you get your chuck pad in front of you,
Yes, sir. Thank you.
okay, once you get your chuck pad in front of you, do you have an IV bag, Georgia? No. Raina, could you hand her a normal saline bag, please? None of you have IV bags then? All right, let's get some IV bags. In that one box, grab an IV bag for each of you, a small IV bag. Okay, so if you'll watch me now, what we're going to do is tip our IV bags upside down. You get your IV bag, tip it upside down so that this is pointing upward. Flip it. There you go. And what we're going to do is we're going to take this out, okay? Pull the spike out. This spike is like a phlebotomy needle. It's sterile. When we open a bag, it's sterile. So we're going to keep holding our bag, okay? Just pull it out, Haida. Yep, pull it out. Yep, there you go. Now, while you're holding this bag, this would have been a closed bag. I want you to use your other hand, bless you. I want you to use your other hand to open your IV tubing bag, okay? And I know, right? Open your IV tubing bag. And we're all having trouble opening our IV tubing bags.
Okay, you gotta put the phone on.
You got it? I don't. There it is, there it is.
You want me to do it for you?
Yeah, come on. This is like zip closed. Thanks so much. Perfect. Thank you. Okay, so 15 drops per ml. I want you to take a look at this tubing. We have to be able to fill this without emptying our bag, okay? And we have to be able to make sure that there's fluid in the drip chamber, as well as making sure that this is spiked. So before we take this cap off, because it's sterile, okay, we want to take a look at our tubing, inspect our tubing. We're the lock on this, the little lock that has that can close and open the tubing. Right now, I want you to make it so that it easily moves up and down the tubing, so it's not locked. We're not going to lock this. So this piece should be able to allow the tubing to move freely up and down. It's not locked, okay? Now here's what we're going to do. When you're ready to spike the bag, because you only have about 3 seconds, you're going to take this cap off, like this, and you're going to spike the bag. Keep it down. Spike the bag. Put it in just like that. Put the top of the spike into the bag. Everyone did that?
Yes.
Don't turn your bags yet. Take the top and put it into the bag. Yes. Did you take yours off? Is that new?
No, this old.
Take the old tubing off and
No,
use
this,
the...
yeah, I just did this.
Okay, and then, no, you need to use your new tubing.
New one.
Use the new tubing. We're taking the old tubing off because it's got air bubbles and all kinds of stuff in it.
Come from this.
Okay, now that we've done that, is everybody where I'm at?
Yes. Is this right?
Yeah, just hold it right there. Don't do anything with it right now. I'm going to show you a trick, and it's always going to work. Now here's what we're going to do next. Close, no, don't close this. Don't close this. Grab this piece at the bottom. Make sure the cap is on. There's a cap at the bottom. It should be on, right?
Yes.
I want you just to gently loosen it, just a little bit. Keep it on though. Just loosen it just ever so slightly. And now what we're going to do is the following. Let me
Was
know.
it with this?
The cap at the bottom should still be on. Just loosen. Don't take it off because this is sterile as well. We don't want it. We don't want this to contaminate. We're going to put this in. We would put this inside of our IV we just started, right? Okay. So now what we're going to do is I want you. You can let go now of the other hand. I want you with your non-dominant hand to crimp the drip chamber. Actually crimp it almost in half like this. Crimp it. Crimp it just like this, so it's bent in half. Crimp it, yeah. Now watch what I'm going to do. Now take the IV bag, okay, tip it over, open the drip chamber. Watch. And it should come out. Lock it now. Everybody lock it, because we're going to leak all over the place. Now lock it. Guess what? Nobody should have any bubbles in their IV. Nobody. Nobody should have any bubbles in their IV.
We have to lock it, yeah.
Keep this down.
Lock it.
Keep this piece down. Lock it, or you're going to lose all your fluid.
Not from here.
Yeah, lock it from here. Lock it from here. You should be able to look at your tubing and not have any bubbles in it now.
That's awesome.
Now you just learned something that they don't even teach you in nursing school. And you didn't lose your fluid, and take a look at your drip chamber. If this is locked all the way, your drip chamber shouldn't really be dripping. Gravity might drip it though, okay? Okay, so, did we do it?
Yes.
Wasn't so bad, right?
No, that was easy.
That wasn't so difficult, was it? Usually when you have to hang bags with gravity drip, one of the biggest things is bubbles in the tubing.
Yes.
Bubbles in the tubing will get you every time.
Bubble here doesn't matter.
No, you need water in here. You need your saline in here, but you don't want any bubbles in here.
The two of them, yeah.
So you guys did great. Good job. Now go ahead and lock this for now. Set it on your Chuck's pad. Raina, can I have a Chuck's pad over there?
This one?
Leave it open. Yep, you don't want it full. You don't want to squeeze it. Just leave it. It shouldn't be full because you're going to have to calculate a drip rate in a minute. Thank you so much. All right, set them down. Everything should be locked so they're not going to be leaking. Now let me show you why drip rate is so important in calculating how fast the drops should come in the drip chamber, because the drip chamber, you should be able to see it. See, you should have this much space. Lena, you have no space in your drip chamber. So tip it upside down and squeeze some of that fluid back into the bag, okay? So you should have at least space enough to be able to see inside the drip chamber. If you don't, tip it upside down and squeeze some of it out of the drip chamber. Okay, if your drip chamber is too full. Okay, so let's take a look. We have an IV bag that says the drip factor is 15 mLs, right? Or sorry, 15 drops per ml. That's a given. That's a constant, isn't it? What does a constant mean?
Doesn't change.
Exactly, it doesn't change. So now let's take a look at a doctor's order. Let's say a physician wants to give a patient 1,000 mLs over 12 hours. That's the doctor's order. Okay, he says, Oscar, can you start an IV on this patient? We need this patient to get 1,000 mLs over 12 hours. 1,000 mLs of, let's say, normal saline. 0.9 normal saline over 12 hours. What's the drip rate? How many drops per minute is what our goal is going to be. Okay, we want drops per minute. That's our end goal, because that's what we have to program for a non-standard IVAC. We're not using an IVAC. We're using a gravity system where we have to literally watch the drip chamber and count how many drops in 1 minute. Okay, so what are we going to start out with? The best way to learn how to do mathematical calculations in nursing is to always start with what's ordered. Start with what's ordered. Well, what's ordered is 1,000 mLs over 12 hours, so we're going to write it as a ratio. We're going to say, okay, so we've got 1,000 mLs over 12 hours, right? And then we're going to multiply by a series of constants so that we get drops per minute. So let's go ahead. We're going to multiply by a conversion of our tubing drip rate factor, which is 15 drops per 1 ml, right? And we want drops in the numerator because our answer is going to have drops per minute, right? Now we've got hours in the denominator, so we're going to multiply by the conversion factor. 1 hour is equal to 60 minutes, correct? Now look what cancels. mLs cancel mLs, hours cancel hours, and I'm left with what? Drops per minute, correct?
Yep.
So we just have to do the math. 1,000 times 15 divided by 12 times 60. And then you have your answer. What does that come out to be?
12 hours.
50. No, we're going for drops per minute. So 1,000 times 15 is what? 15,000, right?
15,000.
12 times 6 is what? 72 or 750? Or 720? Right? Isn't that 12 times 60?
Yeah, 720.
So 15,000 divided by 720 gives us what? What does that give us?
15,000 over what?
Over 720. What does that give us?
2.83.
20.83?
2 point, yeah.
20.83, but 20.83, we can't really gauge that, so we're going to round up to about 21 drops per minute, right? 21 drops per minute. What are the rounding rules? Now, obviously, pediatrics is a completely different field, so I don't even want you to think about that right now, okay? Calculating body surface area and mass. Because that's what we have to do when we're giving medication to children, because their body surface area and their mass is much less than ours. But we can round up in a gravity drip at 21 drops per minute. So how do we do that? Well, basically, we're gonna hold this up, and we're gonna look at the clock. And what we're gonna do, right now, mine's not even dripping. Probably yours isn't either. You hold it still. So we have to open this ever so gently so that we can start counting how 21 drops in 1 minute, right? So let's look at the clock, look at the second hand on the clock, and see if you can't get approximately 21 drops per minute. 1, 2, 3, 4. Too fast. 1, 2. 1, 2, 3, 4, 6, 7, 8, 9, 10, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. A little slower. Make it a little slower. A little slower. See, I want you to arrange it so that you're getting about approximately 21 drops in 1 minute. And that's about right.
This is our job or the nurse job?
No, it'll be the nurse's job, but you need to know it. If you start to, hey, look, if you work in a physician's office as a medical assistant and you're doing infusions, he's going to want you to know this, okay?
Yeah.
Can't get out of it that easy, Miss Lynn. That's what you signed up for. Okay, so I want you to count till you get 21 drops. Takes a minute, doesn't it? Do you know in nursing school we had to do this with a nurse looking over our shoulder? I mean, literally, they were standing right here and they were counting with us. Talk about pressure. And she'd mark us off if we were like 1 or 2 drops off. And this is gravity feed. You know, sometimes if people move their arm or something like that, it's going to come down faster. So yeah. That's why you need air in your drip, you need room in your drip chamber so you can count it. Okay, so we're going to do this again. Okay, so go ahead, put your bags down. I'm going to show you another calculation. I want you to try this on your own. Okay, here, let's do another one. Let's do another one, everybody. Leave that as a constant. Okay, so we have 500 mLs of Rocephin in a normal saline mixture, and the doctor wants the 500 mLs to be infused over 500 mLs. He wants these infused over, say, 6 hours. How many drops per minute? We're going to set it up the same way, right? So what are we going to start with? We're going to start with what the doctor ordered. He ordered what? 500 mLs over 6 hours, right?
Yes.
That's what he ordered.
Yes.
Don't have to worry right now about the medication. We just have to calculate the drip rate. Next, we're going to use our drip rate constant factor, which is 15 drops
Over
per 1 ml. And then we have to change to minutes, so we've got hours here, so we're going to say 1 hour is equal to 60 minutes, right? Same setup, exactly, just different numbers. You can actually write this down with the drip factor, with this, and all you're going to change is this. It's going to be the same problem every time, unless I try to mix it up for you and make it harder, which I'm going to. Okay, so what do we get when we multiply this? 500 times 15, right?
15.
And then 6 times 60.
yes.
And what do you get when you divide the numerator by the denominator? What do you get? 500, or 5 times 10 to the second power. 5 times 15 is 75 times 10 to the second power, or 7,500. 6 times 60 is what? 360, right?
So I'm guessing it's 10 and a half per minute. I mean,
All right, wait, I
Because we
need,
have the 12 and then we got the half.
okay, I need a number though.
21.
What is it?
20.83.
Again, how did we do that? That's so cool. We just got the same exact number. Isn't that cool how that just worked out? How did I even do that? How did I even guess that? That's so cool. 20.83. 20.83 is going to round up to what?
21.
21. Let's look at rounding. Let's look at the rounding rules, right? It's been a minute since you've probably looked at rounding rules, right? Let's take a look at rounding rules for just a second. So basically, let's say I have 22.83. I have 22.83, right?
Yes.
Let's say we have to round to the nearest ones place. This is the ones place, isn't it?
Yes.
This is the tens place. What place is this? Tenths place. What place is this? Hundredths place. So if I have to round to the nearest ones place, I'm going to look at the tenths place and I'm going to see an 8. So rounding rules says any number greater than or equal to 5, we round up. Less than 5, round down, or leave it the same. So since 8 is greater than or equal to 5, to the ones place, 2 becomes a what?
3.
A 3. And we have 23.
I thought the one space would be the 3.
No, in the ones place is not the 3.
That's
So,
what I
so,
was
so, so let me show you. Okay, so let me show you this right now. Let me just erase this real quick. Let me just review decimal places for you guys, okay? So 283.7891. Let's take a look at this. 7 is the tenths place because it's behind the decimal. It's to the right of the decimal. 8 is the hundredths place. 9 is the thousandths place. 1 is the 10,000ths place. We're getting smaller, 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 smaller. Do you see what I'm saying?
So without the decimal, it would be the ones place, right?
If I took this decimal away, yes,
Okay.
this would be ones, tens, hundreds, thousands, 10,000s, 100,000s. Right? 1, 2, 3, millions.
Yeah.
But the decimal's here, so it's, then you count this
Yeah.
way. Tens, hundreds, thousands,
Here, can I do something?
10,000s. Yes,
Yeah.
please, come up, Rena.
This is how you
Sure.
look at it. This is your line, this is your 0. This is 1, 2, 3, hypothetical. And then the decimal is gonna come on this one. This side is gonna be minus, this side is gonna be plus. So this, 0.1, 0.2, 0.3. And then you could, so this is minus, this is plus. So I'm looking here, whenever I see on top of 5, that's mean 284. Less than a 5, well, I got confused. Then it's gonna be 283 and I stick
This is
with
more
that.
than 5.
What? This is more than 5. Then it's gonna be to 6. Less than 5 is gonna be to 4. So this is really important, this number right here. And I go from there. So
Thank you.
this is minus. I'm going
Oh, no,
backward.
I'm understanding how to round off. I just, the decimal
The
would throw
decimal-
me
the
off.
decimal
Decimal
places-
is going back, like, you know?
Yeah, it's getting smaller. Decimals are
smaller.
getting smaller, yes. I'll just tell you, what you did right there is like calculus to me. I'm, that, you just totally, I have to, no, you're fine. I'm just gonna have to rethink everything. That's very good. Could I get another checks pad just to, oh no, some paper towels, sweetheart. Okay, so let's take a look at another problem, shall we? I'm gonna let you guys do this on your own, and then we're gonna bump up the level of difficulty.
We will have calculations in the test.
You are gonna have calculations in the test, absolutely, and they're gonna go over hypertonic, hypotonic, isotonic,
But
all that good stuff.
Same idea, exactly.
Same idea, yes, same idea. Okay, so let's take a look at this one. The physician orders 250 mLs of, let's say, Solumedrol, no, piperacillin, let's do piperacillin. Over
5 hours.
4 hours. I was gonna say 5, 250 is not long. Over 4 hours, okay, 4 hours. Go ahead and calculate, what is the drip rate drops per minute, okay? Take a minute. What is the drip rate per minute for 250 mLs over 4 hours? Let's see if you guys can do this.
Per minute?
Yes, drops per minute, yes. Let's calculate drops per minute, everybody. Take your constants, take a look at them. It's no longer going to work. Okay, how many got it already? Oh, my phone's hurt.
15.6, yeah.
Okay, I'm hearing some numbers now. What did you get?
It would be 16, right? You rounded?
16?
Yeah.
16 drops per minute?
Yes, ma'am.
So everyone, is Oscar and his group back there, 16 drops per minute?
Yeah.
All right, let's take a look and see if they're right. We start with what's ordered. What's ordered?
250.
250 mLs over what?
4 hours.
4 hours. Times our conversion factors.
15
15 drops
Yeah.
over ml
per 1 ml, good. Times
No, you don't
1 hour
over 60.
over 60 minutes. Good.
250.
You guys got 16 drops
16 drops per minute.
per ml, per minute? Okay, so what do we do? Did you guys set it up like this? Did everybody set this up like
Yes.
this?
Yeah.
Yes.
You're just replugging in numbers, that's all you're doing, right? Same formula, just plug in different numbers.
But 15 drops per ml, it's standard for everyone.
Well,
All
it
the
depends.
calculations.
Yes, for now it is because of what? Our tubing, right?
Yes.
It's standard because of our tubing. It wouldn't be standard if your tubing wasn't 15 drops per
Yes.
ml.
But we will
It's
have
all
that.
based on your tubing.
Yes.
Good job. Okay, let's do it. 250 times 15 is what?
3,750
3,750.
over 240.
240.
Which is equal to
15.6.
15.625. Which is round up to 16.
15.625.
Yes.
Beautiful. We look at the 6. Is it greater than or equal to 5?
Yeah.
It is. We round the 5 to a 6. Yes.
I thought you said the standard rate would be 10.
We're working with the tubing that we have, which is 15 drops per ml. So you don't want to change the rate of the tubing unless I tell you the rate of the tubing is going to change. Okay, did you work it out with 10?
No, I didn't.
Oh, okay, good. Yeah, we're going to switch up tubing in just a minute. Okay, any questions on this?
Okay.
God bless you. Yeah, it's pretty standard, right? Now let's change the equation, everybody. Let's change the equation, shall we?
Yes.
Let's take a look at something else. First of all, there are some constants that you need to know. There are some regular constants that everybody needs to know in the medical field. You need to know that there are 1,000 mLs per 1 liter, right?
Yes.
You need to know there are 2.2 pounds in 1 kilogram. You need to know that 1 liter is approximately equal to 1 kilogram. This is what we use in dialysis calculations.
Don't ask me.
Um,
Do you remember what happened last time?
Yeah, yes.
and there are 60 minutes to 1 hour. Oh, Miss Kathy, can you?
Yeah.
Here's my card. So much.
60 minutes and per 1
60
hour.
minutes and an hour, exactly. Okay, so now let's take a look at our next problem, shall we? So, as a new medical assistant, you come onto the doctor's office. He's already got a patient sitting in the chair. This patient's been in the chair now for about an hour. We are infusing approximately 750 mLs, okay, of, let's say, of a solution that this person needs. Say it's an electrolytic solution. So the patient's sitting, the doctor's original order is 750 mLs of solution over, and this patient's going to be in his office for about 6.5 hours. Over 6.5 hours. So this patient's going to be there almost the entire day, getting this IV solution. Okay? Maybe it's cisplatin, maybe it's diluted with something, maybe it's methotrexate diluted with something, because it's hard to give it infusion, you know, completely full strength. So let's just take a look. So 750 mLs of solution over a period of 6.5 hours. The drip rate's the same. Our drip rate, we know, we checked the tubing, it's 15 drops per ml. Okay, this started, they started this at 9 a.m., so at 9 or 0900 hours, the patient started giving 750 mLs of solution over 6.5 hours. It's 0900. You came in at 1 o'clock. So, over 6.5, and so at 0900, 750 mLs of solution over 6.5 hours began. At 1300 hours, okay, you arrived. To find the bag with 250 mLs left. Okay, let's see, let's read this again. Let's read this again, because now it's getting like crazy, right? Now it's like, what happened to the easy calculations?
Yes. Call the nurse.
Yeah, it's just, hey, I need your help. Can you figure this out? At 900 hours or 9 a.m., the doctor began a 750 ml solution over a period of 6.5 hours. It started. At 1 p.m., your shift began. You find the bag, the person sitting there with the bag, and there's 250 mLs left. The question is that correct?
Correct or wrong?
How much should be left in the bag and what is the current drip rate? So, two questions. It's a two-question problem. Is this correct? Is that the correct amount of fluid that should be in the bag? And what is the correct drip rate? Maybe that is how much should be in the bag. What is the correct drip rate? So, drip rate in what? In drops per what? So there's two things we want to find. Two things in this problem. We want to find out, okay, this patient's going to be on infusion from 9 for 6 hours. 9, 10, 11, 12, 1, 2, 3. 3 o'clock. They should be done. All 750 mLs by 3 o'clock should be infused. You come in at 1, and you see 250 mLs left. So you're going to ask yourself, they still have 2 hours, right? That they're going to be in the office. So your job is to check to make sure that 250 mLs should be left, or if the drip rate's not correct, we have to correct the drip rate so that they'll be done by what? By 3 o'clock, correct?
It says 6.5, that's an hour and a half, and 3:30.
Yes, I'm sorry, 3:30. Thank you, Haida.
Yeah.
I appreciate that, 6.5. Excellent powers of deduction.
All right, no problem.
You're all over this.
Yeah, all right.
So I want you to think about this for a minute now. There's 2 ways that you could solve this. You don't have to take the long way around. There's one easy way that it can be solved. I want to see if you can zero in on that. I like to solve things very convolutedly. I'm all about, that. But if you can see an easier way of solving this, which I see, you might be able to get it. So let's take a minute and try to solve this problem and see how we can come up with the answer, okay? And then what I'm going to do is give you another problem, okay? And we'll work on some problems, then we're going to call it a day, okay? A couple more problems.
So we're still at 15 drops per milliliter.
Yes, yes, we're still, yes, right. The drip factor is going to stay the same, 15 drops per ml. So the drip factor hasn't changed. Start with the same setup that I gave you originally. That's what you should do. Start it with the same setup I gave you originally. And then we'll solve it together, okay? So we've got 750 mLs over 6.5 hours. Let's see if you guys can solve this. Now that you know how to insert IVs and everything and how to spike bags, now all you have to know is how to calculate. You know, everything in this field is dimensional analysis. Well, yeah, you're going to find the drip rate, the correct drip rate for what we have to correct for what? 1, 2, 3, 2.5 more hours. They're going to be on the chair technically for 2.5 more hours. Now we need to know if 250 mLs should be left in the bag, you know, at 1 o'clock, at 1300 hours. That's something we as nurses have to do regularly. It's crazy. When we walk into a room and everybody's gravity drip, we have to recalculate to make sure that their drip rate's flowing normally. It is crazy. It's insanity. But it's okay. You get used to it. How are we doing back there?
I first try to find like the bad, the wrong drip rate.
Right.
At 29, and then since it's after 4 hours, so that's 10 drips per minute, right? So if it's doing it after you put it back again, so I'm doing it 6 drips per minute times 60, and then I'm doing 29 times 60. It's like that'll give me the drops per hour. But then I lost after that.
Okay. You're on the right track. You solve things like me. Okay? Very convoluted. I like that. Okay, we're gonna take this problem apart right now, okay? Let's just take it apart. Let's just take it apart, solve it, and get it over with. Because it's hurting our
750 ml over
it's hurting our
6.5.
brains. Yes. So okay, let's step over here. Let me do it over here. Let me erase this. And let's do it over here. So I'm gonna show you something. I have 250 mLs left. You're gonna hate me on this one.
Mm-hmm.
You're gonna hate me. Watch what I'm gonna do. I'm gonna start throwing spitballs at me in just a minute.
I'm gonna minus it.
Okay, watch. How many hours do I have left?
4.
No. 1, 2, 3, 2.5 hours, right?
Yeah, 2.5 hours.
Okay, so here we go. 250 mLs over 2.5 hours times 15 drops per ml times,
1 over 6.
yes, 1 hour over 60 minutes.
But first, the numbers I don't know.
So mLs cancel mLs, hours cancel hours. The first thing I'm gonna do, since I know they've got 2.5 hours left, is I'm gonna fix the drip rate. That's the first thing I wanna do is fix the drip rate. I don't wanna go in too fast. I don't wanna go in too slow. I know she's got 2.5 hours left, correct? Pretty much, right?
Right.
So let's solve this first. So 250 times 15 times 1 equals Numerators multiplied by numerators. Denominators, 2.5 times 60. Okay?
See
60
the 2.5
is the hours left,
the hour left.
right? You come in at 1 o'clock?
Yes.
They're supposed to be done at what? 3:30. How many hours is that left? 1 to 2, 2 to 3, 3 to 3:30. It's 2.5 hours left, right?
Yep.
Yes.
25.
So what are you getting?
25.
25 drops per minute.
Exactly.
Okay, so exactly no remainders. Okay, so we get 25 drops per minute that we have to set the drip rate to. How do we know if that is the original drip rate that we started with? We don't. We don't know if they had them on the right drip rate because there's 200 and what? 50 mLs left in the bag. So let's take a look. Let's go right to the beginning, like Lena was saying, and set it up. The doctor orders 750 mLs.
I can give you the answer.
Oh, hang on, hold on, I'll let you jump on that in 1 minute. 250 mLs over 6.5 hours. Okay, cool.
Times.
Here we go.
15
15 drops per 1 ml, excellent. Times,
1 over 6.
you guys are amazing, over 60 minutes. Okay, cool.
Which is equal to 29 per minute.
29 drops
Per minute.
per minute.
Yep. So I'm 4 drops short.
Yeah.
Yeah, I'm 4 drops short.
4
which is
drops
when I
short.
have to
So
adjust-
basically they were going a little too fast, weren't they?
Yep.
We had to what? Slow it down.
Down.
Not too much, right? We didn't have to slow it down by too much. They were pretty much, you know,
In the range.
right on track. Yes.
So that's what you're saying, when it first started, it was at 29 drops per minute. By the time we got there, it was 25. When we first saw it.
When we got there,
It was 25.
when we got there, yes, it was 25. So,
No, sorry. When we got
No,
there, it was so 29, but we have to switch it to 25 to finish by 3:30.
yes,
Okay.
yes, exactly. You had to finish it. So we got there, it was 29 drops per minute. But as medical professionals, we have to verify, is that too fast? Is that too slow? We don't know. What do we got? So we look at what we have left over the amount of hours that's left, yeah? And we come up with how many drops per minute it, what, should be. So they were going a little bit too fast, right?
Yep.
About 4 drops per minute too fast. 4 drops per minute, give or take. That could just be gravity. They're moving their arm, they're getting up, they're going to the bathroom. It goes faster. So actually, we're pretty darn close, aren't we? We're pretty darn close, right? So what we did here was, the question is, if we,
I didn't open it.
do me a favor, what's 750 divided by 6.5? Yeah, just give me that answer. I want to show you something.
115.
What is it?
By what?
Okay, 750 by 6.5. What do you get? Shout it out to me.
115.
115. So we're going at 115 mLs per hour, right? Okay, watch. So we got there at 1. So we ran from 10, 11, 12, 1. Now multiply that times 4. 115 times 4, what do you get?
4?
Yeah,
4 61.
4 hours.
Yeah, 4 or 6.
Times 4 hours, what did you say it was?
460.
460?
Yeah, no,
461.
461.
Yep.
So basically 461 mLs transfused over what?
Over the 3, how much
4
hours?
hours.
4 hours.
2 hours and a half, right?
No,
No. Follow me here. What am I doing? Look, what did I say? 750 mLs in 6.5 hours.
Hours.
If I divide this into this,
Yeah, give me.
I get what? I get 150 mLs per hour, right?
Yeah.
9 o'clock it started. That's how many mLs per hour have to infuse. 9 o'clock it started. We came in at what? 1. How long has it been infusing?
4 hours.
10, 11, 12, 1. 4 hours. That's why I'm multiplying 4 times 115. What do we get? You guys told me it's 461.
Yeah.
So what's left in the bag? In 4 hours, technically, this is how many mLs should be left in the bag. Right?
All right.
But how many mLs were left in the bag?
I
2
got
hours.
some.
Okay, 2.
It was going too fast.
Yeah.
So
Yes.
I get 50 divided by 6.5 is 115. Oh, where's the 150 stand for again? I kind of lost you.
The 115?
It stands for what?
Okay, so take look at this problem that I have here, right? So basically, if I take 750 mLs,
Yeah.
almost a liter,
Okay.
250 shy of a liter, and I divide it by 6.5 hours, how many mLs is that per hour?
150.
115
Yeah.
mLs per hour. You follow?
Yeah.
We came in at 1. So
Okay.
technically, if it's supposed to be 150 mLs per hour, 4 hours later, we had how many mLs infused?
460.
461 minus what? 750.
Yeah.
So 750, let's take a look. 461. That 10 take away 1 is 9. Cross out the 5, make it a 4. 14 from 6 is 8. Cross out the 7, make it a 6. So basically, there should be 289 mLs of fluid. There should be 289 mLs of fluid left. Instead of 289, there's 250. Which accounts for what? The 4 mLs of difference. You can actually calculate using the 4 mLs and multiplying to find out how much faster it was going, but I'm not going to hurt your brains with that, okay? That's just craziness. Start throwing spitballs at me now.
No.
So do you see what I'm saying?
Yeah.
No,
I totally
No.
understand.
Okay, where did I lose you?
I'm not understanding like the 25 pounds.
Okay, where are we? 25. 25. All right. So how do we get to 25 drops per minute? Let's start
I
from
thought it
the.
was supposed to be 29.
Okay, yes. This is what it's supposed to be. Yes, that's what we decided. It should be 29 drops per minute because we took 750 divided by 6.5 times our drift factor of 15 drops per ml. You're right.
Okay, I thought you said 25. That's why I got confused. Okay,
So
then
so
never mind.
basically, it should have been 29 drops per minute.
Okay, I got it then.
Cool.
I'm sorry.
No, you're fine. Great question. Anybody else? Any questions that I can clear up here?
Is it another way you can do that?
Yes, I did show you another way.
Another way, cause like I subtracted the 750 and the 250. Well, 250 from 750. And I had got 500 mLs.
Okay, and then you calculated the drip rate? Did you come
I
up
mean,
with
is
the
that a
same
right
answer?
way?
It depends on what your goal is.
No, I
See,
stopped there.
you see, yeah, because you need to know what your goal is. You can't get to a goal if someone gives you, see, this is math. Let me just explain something to you. Don't be afraid of math, okay? I'm going to tell you why. Because math is a state of mind. If somebody puts you in a maze and you know what your goal is, it's to get out of the maze, right? You're going to find a way to get out of the maze. So with math, you have to have a goal. You have to have a way to get to your answer. If you don't know what you're supposed to do to get to your answer, you're kind of stuck. So the first thing you always have to do in math, and this is how I got better at math, is not sit into the mass confusion of mathematics, but say, okay, here's a problem. This is my problem. How do I get to the answer? What's my goal? Every step you take is going to get you closer to your goal. You just have to know the steps. Once you can identify your questions, that's where you become good at math. You've got to understand what questions you have to ask, okay? And that's where your teacher comes in. So, if we take a look at this, we can kind of sum it up on how we can do that, right? All right? Okay, so what I'm going to do right now is give you one last problem, and then we'll let you guys go, okay? I think you guys feel like I've worked out your brains, okay? Did we cover all of Bloom's taxonomy of theories of learning? You guys read about that, right?
Yes.
Your cognitive, your affective, your psychomotor, we've done it all.
In the test, we'll have like this
Yeah, you will.
complicated.
You will have it complicated. Maybe not to that degree. This isn't really too bad, but, okay. Let's do another one, okay? Let's make it a good one that you guys feel good about yourselves on. Okay, let's do another problem. One more. Here we go. All right, we're gonna infuse 600 mLs of 0.9 normal saline over 7 hours. What's the drip rate? Here you go. What's the drip rate? You guys are gonna get this, I know. Drip rate, 600 mLs of 0.9 normal saline over 7 hours. What's the drip rate?
It's still 15.
What is it?
The standard's still 15. The standard-
15, yes. The standard is still 15 drops per ml for IV tubing drip rate.
One.
21, man, I heard that in unison. 21 drops per ml. Did everybody get that? Are we good? Who needs help? Anybody need a little help? Remember, numerators get multiplied by numerators, denominators get multiplied by denominators, and then you divide. It's always the bottom number that divides into the top number. All right, let's just put it on the board to see how we came up with it so we all have the same. So what did the doctor order? 600 mLs over 7 hours, right?